This is another 2023 number challenge. We try to find the last 3 digits of the number 2023 raised to 2023's power. Now usually to find the last 3 digits is equivalent to find what is the remainder when divide this number n by 1000. This kind of programming language notation here. Or in mathematics, we would like to do the modular arithmetics for the mod 1000. Now the way to do that is to factor 1000. You know that 1000 is 8 and 125. So what you want to do is to find out what is the remainder when divided by 8 and what is the remainder when divided by 125. Now for 8 and 25, for the power of a number, we know that it's congruent to whatever the base mod 8. So we can make the number smaller from 0 to 7, right? So in this case, 2023. And for the 2023 mod 125, same thing. You want to look at what is the mod 125 for the base, which in this case, 2023. All right? So the answer of these two questions are easy. For the first one, the remainder is going to be 7 or -1, because 2024 would be a multiple of 8. So 2023 would be -1 here. Now for the 125, it's going to be 23 again. Okay, so that's 2000 is a multiple of 125. So the remainder is 23. So our question comes down to try to find out what this number mod 8, right? And earlier we said that the base 2023 is -1. So the whole thing is going to be congruent to -1 raised to 2023rd power. Okay, so this case, of course, -1's power is easy. That's -1. Okay, so we know this big number is going to be remainder -1. In other words, remainder 7 mod 8. Okay, so let's move on to figure out mod 125. Okay, so here the base again is 23. Yeah, so we are looking for 23 raised to 2023rd power mod 125. This has to do what is the order of number 23 in modulus 125. Now if you review some of number theory and background, is that for the order in this group is going to be always a factor of phi 125. Phi is Euler torsion function that counts the number of relative prime factors relative prime to 125. So what is the order of 23? That's what we need to do, right? Now we know that phi 25 is actually 100. So 23's order is going to be a factor of 100. In this case, it turns out that 23 is actually the order 100. Okay, so looks like we need to figure out what is 23 raised to 2023, but then since order is 100, so which means for every multiple of 100, we can just because that's going to be 1, right? So that's 23 raised to 100's power is congruent to 1 mod 125. So this number here is going to be, you get rid of the multiple of 100 for the exponents here, so the exponent becomes 23. So our problem comes down from a big number in a big base and big exponent, now down to base 23 raised to in this case happens to be 23's power, mod 125. Now how do we do that? Since the order is 100, does it mean that we have to calculate 22 multiplication in order to figure out the number? The answer is no. Now here there's another trick in how to calculate the power in modular arithmetics for big powers. Now usually what you do is to express that in a binary format and use what is called the continued power, continued square techniques, so that you can save some multiplication steps. Okay, so what we are doing here is that we try to reduce the number of multiplications of 23 raised to 23rd power, right? So since this is a binary representation of the exponent here, 23, so 23 can be written as this multiplication of 4 numbers here. So each time, notice that this is kind of the square of the previous terms, right? So what you can do is to do the square, and square of square would give you 4th power, and square of 4th would give me 8th, and square of 8th would give you 16. So let's do that. So multiplication, first multiplication we're going to do here is figure out is 29. Now we need to do the 29, which is this one to square to figure out 23 raised to the 4th power. Just square up this, that's 91, mod 125 of course. And the next one would be 23 to the 8th and the 16th. Okay, so what we're doing here, we have 4 multiplication, and then we got this, and then here we can just multiply them together to get 23 to 23's power. So we have another 1, 2, 3, a total 7 multiplication in order to give the answer, right? So after 7 multiplication, you get the number 67. Okay, that is better than if you do the brute force of 23 times 23 times 23 for, you know, in order to have 23rd power, you have 22 multiplications, right? Down to 7 multiplications. Okay, that's a technique in the real implementation of the, you know, the exponents. What we get is for mod 8 is -1 or 7, and mod 125 is 67. Now, with that, of course, it's equivalent to say, what is number x that satisfies both equation here? That's Chinese remainder theorem for system of linear congruence equation. So we can solve that, and the answer is 567. That's indeed the answer for 2023 raised to 23's power, the last 3 digits. Okay, in summary, what we have learned today is some modular arithmetic and also some tricks in doing the large power of integer in modulus operation. Okay, hope you follow the steps. Please like, share, and subscribe to the channel.